This is the ATP/PC system, also known as the phosphocreatine system. The site and speed of the reaction is that the chemical reactions take place in the sarcoplasm. This is a very quick reaction because the phosphocreatine is stored in the muscle cell and it takes very few steps in the reaction. The fuel used in this energy system is creatine, and it is 120 grams is stored in the body and most of it in the muscles. The controlling enzyme of this energy system is creatine kinase. The ATP production is one molecule of ATP from one molecule of phosphocreatine, and it has no harmful byproducts that will cause fatigue. The exercise type that suits this energy system is usually high intensity exercise, such as the high jump when you're jumping up, exploding off the leg, or kicking a football. This action only usually lasts between 8 to 10 seconds. This is the lactic acid system, also known as anaerobic glycolysis. The site and speed of the reaction is that the chemical reactions take place in the sarcoplasm, which is in the fluid in the cell, like a cytoplasm. Also, it has relatively few chemical reactions, so ATP is provided quickly. The fuel used is carbohydrate, which is glucose, stored in as glycogen in the muscles and the liver. The muscles are more accessible. The controlling enzymes are phosphorylase, which converts glycogen to glucose. Also, PFK, which stands for phosphofructose kinase, which converts glucose to pyruvic acid. Also, LDH, which converts pyruvic acid to lactic acid. The ATP production is 2 molecules of ATP, which is twice as much as the ATP energy system, but it takes longer but produces double the amount, so it's more efficient. The byproduct is lactic acid. This reduces the pH of the muscle cell, making it more acidic. This prevents the enzymes from functioning properly, causing muscle fatigue. The exercise type suitable for this energy system is high to medium intensity, which is up to 2 minutes, and an example of this is the 400 meters or the 800 meters. Now on to the aerobic system. The site and speed of the reaction in the aerobic system is in the sarcoplasm and mitochondria, and this is aerobic respiration. Due to the requirements of oxygen, ATP cannot be resynthesized immediately. There is a delay while the oxygen is transported from the lungs to the working muscles. The fuel used is carbohydrate, glycogen, and also oxygen. Fats can also be used as a fuel. The controlling enzymes are the same as the lactic acid system, as it is the first stage of the aerobic system is the same. It is phosphorylase, PFK, which is phosphofructokinase, and LDH. The ATP production is 38 molecules of ATP from one molecule of glycogen. 2 ATP is stage 1, and this is glycolysis. 2 ATP is stage 2 as well, which is the Krebs cycle. 34 ATP is stage 3, and this is the electron transport chain. The byproducts are harmless byproducts, carbon dioxide and water. The exercise type which is suitable for this type of energy system is it cannot provide ATP whilst working at high intensities due to the time taken to provide oxygen to the working muscles. Therefore, anaerobic systems have to supply energy for the first few minutes of exercise. Low intensity activities can last for hours. A suitable example for this is the 1500 meter run or a 5000 meter run.